Alright, let's take a look at sketching another rational function in the form of f of x is equal to axn plus c over bxn plus d. Okay, so once again, this is a rational function where the degree of the numerator and the degree of the denominator are the same, right? And we stated that the restriction on y could not equal a over b, right? So this actually represents the horizontal asymptote. So this was in terms of the range, and this is a restriction on the range, and we know that the horizontal asymptote is thereby a over b. Okay, so let's keep that in mind, and let's take a look at some of the characteristics of this function. So in this case, let's start with the domain. Domain, x belongs to all real numbers. We're looking for a value where the denominator would equal 0, which would basically make the function undefined. So in this case, x cannot equal -4. Okay, the range here, we stated that y cannot equal a over b. Well, a and b are the coefficients of the degree, and they have the same degree. This only works when the degrees are the same. It doesn't have to be 1, right? But you have -2 here, and you have 1 here. So in this case, you do -2 divided by 1, and as a result, y belongs to all real numbers, but y cannot equal -2. Okay, now that you have this, what you want to do is write down your asymptote. So your vertical asymptote is a restriction on the domain. So x cannot equal -4. The horizontal asymptote is restriction on the range. Y cannot equal -2, and y is, in this case, the horizontal asymptote is equal to -2. Okay, so keep this in mind. So once we have the asymptotes, we can also figure out the intercepts. So for the intercepts, let's start with the x-intercept. So we stated that for rational functions, the x-intercept was just as easy as setting the numerator to equal 0. So we have 6 minus 2x is equal to 0. And if you wanted to solve for this, I would move the 6 to the other side. You get -2x is equal to -6. If I divide this by -2, x is equal to 3. So the x-intercept here is 3 and 0. Okay, so this is pretty useful. Okay, so now we have the x-intercept. And then what we want to do is we also want to find the y-intercept. Right, to find the y-intercept, I'm going to look at f of 0, which is 6 minus 2 times 0 over 0 plus 4, which is 6 over 4, which is 3 over 2. Right, so the point here is 0 and 3 over 2. Okay, so that's your y-intercept. And then what you want to look at is, let's create a sketch using all the information that we calculated from this function. Okay, so I'm just going to create my grid here. Okay, so using a grid, I'm going to plot some of this information that we got from just looking at some of these characteristics. So we know that the vertical asymptote occurs when x is equal to -4. So I'm going to do the vertical asymptote in, let's do red. Okay, so there's a vertical asymptote when x is equal to -4. Okay, so this is our vertical asymptote. I would really suggest using a ruler for this, guys. X is equal to -4. Okay, so it goes down here. And we also have a horizontal asymptote when y is equal to -2. So let's say that it's somewhere here. Okay, so this is my horizontal asymptote when y is equal to -2. And in this case, you want to plot your x and y-intercept. So let's plot our x and y-intercepts. Okay, so our x-intercept is 3 and 0. Okay, our y-intercept is 0 and 3 over 2. So it's about 1.5. Using our x and y-intercept, we can create a sketch of the function, right? So I'm just going to sketch this in orange. And you can notice that if we connect the 2 here, right, and you guys can make a much more refined sketch, right? You can make a much more refined sketch by creating more test points, so it's fine. So we just need to create the sketch because we just want to identify the behavior, and we're going to follow the asymptotes this way, right? So just by looking at this, we have a sketch, right? And the last thing we wanted to do here is let's check out our end behaviors, right? So we're trying to find our end behaviors. We're trying to find our end behaviors. Let's start with as x approaches -infinity. As x approaches -infinity, as I go this way, y actually will approach -2 from below, right below the horizontal axis. The horizontal asymptote. Then we also want to check the vertical asymptote. You can approach the vertical asymptote from the left side or the right side. Right, so let's say x approaches -4 from the left side. Let's see what happens to y. As we go this way, you can see that the graph will go towards -infinity. And as x approaches -4 from the right side, y approaches +infinity. Right? And you can follow this the orange trace. Right? So as I go this way closer to the vertical asymptote to the right, you can see that the trace is going all the way to +infinity here. Okay, so follow along with that, and then the last step here, as x approaches +infinity, right, y will then approach the horizontal asymptote, but this time it's approaching from above, so we just write -2 positive. Okay, and that is basically some of the characteristics of this function f of x.